Hi everyone, I am Antonusha and I am excited to take you on a brief journey into the fascinating field of space engineering, exploring beyond the skies. From the Department of Aeronautical Engineering, Golden School of Business and Technology. What is space engineering? Space engineering is a unique blend of aeronautics, physics, and technology that deals with the design, development, and operation of systems, which is used in aircraft and spacecraft, from flying within Earth's atmosphere to exploring distant planets. This field pushes the boundaries of innovation. A multidisciplinary field focused on systems operating beyond Earth combines aerospace, mechanical, electrical, and computer engineering. Why choose space engineering? Why should you as a student care about space engineering? Because it's not just about rockets, it's about solutions. Solution for climate change through Earth observing satellites. Solution for disaster prediction through weather modeling. Solutions for global internet access through satellite constellations. So there are some careers which are widely open in satellite design, AI in space, propulsion system, and only thing we need to do is we need to enhance our skills like problem solving innovation, systems thinking. Now, let's look at how space engineering touches our everyday lives. Real world global applications. I have listed down few uh, key points like communication, navigation, climate monitoring, planetary missions, which involves Mars rovers and through James Webb Telescope. India in space engineering. And India is proudly making its mark in this exciting frontier. Since the launch of our first satellite, Aryabhatta, in 1975, the ISRO has been setting global examples of smart, cost effective, and innovation. From Mangalyaan to Gaganyaan. Mangalyaan, Mars Orbiter Mission, Chandrayaan missions, Moon exploration, Gaganyaan, upcoming crewed mission, which attempts to send our first astronauts to the space. So, we are not just participating, we are leading. Space engineering is your future. You can solve Earth's problems from space. Imagine being part of Mars colonization or building India's next generation satellite. So, as we begin this subject together, I invite you to think bigger than the sky. We will learn how gravity works, how spacecraft are controlled, how orbits are calculated, and how India is becoming a space superpower. Let this subject spark your curiosity, fuel your ambitions, and maybe and just maybe take you beyond this world. Today, I will walk you through 5 core units. These are the core units of space engineering subjects. I have been provided 5 unit topics that are Unit 1 Standard Atmosphere, Unit 2 Aerodynamics, Unit 3 Performance and Propulsion, Unit 4 Aircraft Stability and Structural Theory, and Unit 5 Space Applications. Unit Overview. We begin our journey with the roots of aviation. So let me get into in depth of each and every unit. In Unit 1, Standard Atmosphere, I have break down some few important topics which are early concepts and pre-flight experiments, advancement in aviation technology, space explorations and its influence, components of the standard atmosphere, pressure, temperature and density, altitude, impacts on aviation. And in Unit 2, under aerodynamics, we are going to study aerodynamic force, lift generation, shear stress, Lagrangian Eulerian approaches, concept of a streamlined aircraft terminology and its geometry, and also the NACA profiles. In this slide, we are going to discuss about the units 3 and 4. Comes another topic, performance and propulsion and aircraft stability and structural theory. In performance and propulsion, here we focus on how aircraft moves through the air. We explore drag forces and how flow separation increases resistance. The principle of thrust generation, power requirement, available power are essential in designing efficient propulsion systems. So I have brought down important topics from this unit 3 as goes: viscous and pressure drag, flow separation, components of aerodynamic drag acting on an aircraft, thrust generation in a jet engine, power available and power required are determined for an aircraft, thrust calculation. Comes under the unit 4. Here goes: degree of freedom of aircraft motion, control surfaces and their effects, stability in aircraft, Hooke's law and moment of inertia. So why we are studying stability? Stability is somehow crucial for safe flight. This unit explains how aircraft respond to disturbance and how stability characteristics are ensured. Additionally, we cover basic structural mechanics, material behavior, and stress distributions through mechanical properties like modulus and inertia. Finally, we transition from air to space. This unit covers orbital mechanics, which govern satellite and spacecraft movement. From Kepler's law to Newtonian gravity, we explore how space missions are planned, launched, and maintained in orbit. So this slide speaks about the space application, and here we goes the list goes like: history of space research from artificial satellites, upper atmosphere research, spacecraft trajectories, the six orbital elements, Kepler's law of orbits, Newton's law of gravitation. Career importance. What is the need to study space engineer? There are plenty of opportunities which are available when we study space engineering, which I have listed down here: satellite design engineer, launch vehicle engineer, mission control specialist, spacecraft system engineer, propulsion engineer, astrodynamics analyst, remote sensing analyst, a space robotics engineer, space research scientist, aerospace defense engineer, space robotics engineer. Okay. Let the journey begin from Earth to the stars. Welcome to space engineering, and I will be very curious to catch you in my Unit 1 episode. Thanks for watching.